All right, lesson 38 from chapter 5. We're going to go in the opposite direction. I'm going to give you the graph, and then you're going to write a possible function based off of that graph. All right, so here's the steps that you're going to want to follow. There's two real main parts, the x-intercepts and the vertical asymptote. Those two things will give you almost the whole entire graph, and then after you have those, if there's any holes, you'll stick those in there, and then you're just going to have to account for either the the horizontal asymptote or the oblique asymptote and or the y-intercept. Okay, but most of the stuff that you're going to do is going to come from the x-intercepts and vertical asymptotes. All right. So the first thing you're going to do is any x-intercepts you're going to write as factors in the numerator. Any vertical asymptotes you're going to write as factors in the denominator. Any holes, you're going to write those as a factor in both the numerator and the denominator. Then we're going to match the stuff up to make sure that the pieces fit, such as the horizontal and oblique asymptote and the y-intercept. So that's the way you'll do it. So x-intercepts on top, vertical asymptotes on bottom, factors written as factors, holes on both the top and the bottom, and then figure out if you need to multiply by a number to your numerator or denominator to make everything fit. All right, so here's the first one. All right, so you'll see here we have a x-intercept at -4, and we have a vertical asymptote at x is equal to 2. So from what I said on the previous page, since you have an x-intercept at -4, we're going to write that as a factor of x plus 4. Since you have a vertical asymptote at 2, we're going to write that as an x minus 2. And so then we will fill that in, x-intercepts at the top, vertical asymptotes at the bottom. Okay? Then we need to check and see if our horizontal / oblique, horizontal in this case, is going to fit. So because we have a horizontal asymptote at y is equal to 1, from those rules, when you have y is equal to some number besides 0, that means numerator and denominator degree need to equal. Well, they do. This is x to the first, and this is x to the first. So then let's see if our y-intercept fits. So if I plug 0 in for the x's here, I would have 0 plus 4 over 0 minus 2, so -2, which is what it's supposed to be. So my equation then would be f of x is equal to x plus 4 over x minus 2. Let's do another one. All right, x-intercept here at +1, y-intercept at -2/3, so -0.6 repeating. We have a horizontal asymptote here at -2. Vertical asymptote here at 3. All right, so let's work this one step by step here. So x-intercept at 1, so our factor would be x minus 1. Vertical asymptote is at 3, so we'd have x minus 3. Since we have y is equal to -2, so we have y is equal to a number, that means the numerator degree and the denominator degree are going to need to equal each other. So I'm putting these check marks here at the end because when I'm finished, I would actually go and make sure that I got all those parts. So here would be the setup. You'd have f of x is equal to some number, we don't know what that number is, times the x minus 1 on top, x minus 3 on the bottom. Now there's two ways that you can do this. You can plug in your y-intercept, 0 for the x and -2 for the f of x or for the y, and solve for a. That's what I did here. Okay, plug 0 in for the x's, -2/3 for the y, and then solved. So I got a is equal to -2, which would then be my number in the front. Or you could look at this as if you have y is equal to x minus 1 over x minus 3, and these two are both to the first power. And you're supposed to have then y is equal to the leading coefficients written as a fraction. Well, with this being -2, you you would need to stick a -2 in the front there. And again, if you would then plug in 0 for the x's, you would get -2/3 for the y's. So that would be a way you could do that as well. All right, one more. Let's go a little bit harder one. So this one, we've got two vertical asymptotes, a hole, and an x-intercept. All right, so let's run through those step by step again. X-intercept at -2, so x equals, or x plus 2, excuse me. Vertical asymptote, you have two of them, one at 1 and another one at -3, so x plus 3 and x minus 1 is your factors for that. We have a hole in this case at 4, so I'm going to need to use an x minus 4, and I'm then going to place, and then we have a horizontal asymptote here at y equals 0, so that means when I'm finished, my numerator degree should be less than my denominator degree. So on this one, I'm going to go through all these steps at the end and make sure that we're covered. Okay, so we're going to have some number times my x-intercept, hole on both top and bottom, vertical asymptotes in the bottom. So x-intercept, vertical asymptotes, hole written there twice. Okay, and because I have a y-intercept here at -2, I would plug in -2 for the y-coordinate and 0 for the x-coordinate. So if I plug in 0 for all of those, I will end up getting -8/12a. That should equal -2. So if I solve that, just reduce that to 2/3, a would have to equal 3. So here would be my equation. All right, so let's make sure we got everything. Our x-intercept is there. Vertical asymptotes are both there. Holes written twice. Y-intercept, by plugging in 0 for that, I would get -2 for my y-intercept. So that 3 right there is good. So that is how you would write equations given the graph. So that's lesson 38. Let me know if you have any questions.